And I just want to welcome up Lars and Franz to the stage.
So when you think about what I'm trying to say, I really want to hammer this home. When you have a car that's about 5 meters long, and you have people working around it like we did in Model 3, and we change that to this process where we take different parts of the car, and we can do more at the same time, like we did with the Model Y structural battery pack. What you see here is us doing that on the front part of the vehicle, or the rear part of the vehicle. That means we can get more people working on the car, or robots, working on it at the same time. That means we have better operator density, less time doing nothing. We get 44% more operator density, which means more work, less time walking back to the station, 30% improvement in space-time efficiency. And because we're not building it in and out of the car with those slow movements of those robots I showed you from production hell, when we go to automate it, it's going to be a lot easier. In the end, that will probably look something like this, where we balance parallel and series manufacturing in a way where we only do things that are necessary, with a much shorter final line, blocking a lot less of the entire rest of the factory, so we can optimize material flow using the best practices. And what that means, it's going to look something like this, where we build all the sides of the cars independently, we only paint what we need to, and then we assemble the parts of the car once and only once. We put them where they need to go. The interior is attached from a bottom-up or a top-down strategy, so there's more access for those robots and people. We aren't moving heavy objects around and doing nothing to it. And it means we're doing more work on the car more of the time. And then when we take all of these tested sub-assemblies and we put them together, we finally assemble the car only one time, putting the sides on with all of their parts to a front and rear that was already assembled, carrying the floor in with the seats, and finally boxing it out with the doors one time, just like Cybertruck. So in the end, you get the same car, but it's not going to be a Model Y.
Yeah, this is not. Yeah. This is a Model Y for illustration, not the next-gen vehicle.
In the end, what does that mean? To increase the scale and adoption of electric vehicles on the orders of magnitude that we just showed you, we have to make constraints part of the solution. It leads us to greater than 40% reduction in footprint, which means we can build factories faster, with less CapEx and more output per unit. We'll reduce costs as much as 50%. This is the 2-for-1 concept you hear me and Elon talking about on earnings calls.
Yeah, so I think our track record proves that we can deliver the best cars, and we deliver the best cars in spite of, because of these constraints. And I'd love to really show you what I mean and unveil the next-gen car. But you're going to have to trust me on that until a later date.
Thank you, Franz. My name is Colin Campbell, and I have the real privilege of leading powertrain engineering here at Tesla. And the powertrain factory, which is behind me today, is 75% smaller and 65% cheaper than the one that we originally built. In our next powertrain, so those silicon carbide transistors that I mentioned that are key component but expensive, we figured out a way to use 75% less without compromising the performance or the efficiency of the car. And of course, we know that battery cell supply is one of the constraints on the scalability of EVs right now. Our new powertrain is compatible with any battery chemistry. And that will give us great flexibility in battery sourcing. If we want to make EVs more accessible to people, they have to be cheaper. We've reduced the drive unit cost to about $1,000. And we don't think any other automaker is even close to that number. We have designed our next drive unit, which uses a permanent magnet motor, to not use any rare earth materials at all. And this achievement, like all of the achievements that I mentioned today, it's only possible because of the incredible people on our powertrain teams. They are absolutely committed to the cause of sustainable energy, and that is why we can do what no other company can do.
Good afternoon, everybody, and welcome to Texas. For Cybertruck, we are now designing 85% of the controllers in the car. For the next-gen platform, we're going to finish the job and be designing 100% of the controllers to give us full control of the design and the supply chain at the component level.
Thanks, David and Pete. Hey, everyone. My name is Ashok Kelliswamy. I work on autopilot and self-driving. Like I mentioned earlier, the solution to scalable FSD is getting the AI architecture, the data, and the compute just right. And we have assembled a world-class team to execute on this. We're pushing the frontier on these 3 items, and as we improve the safety, the reliability, and the comfort of our system, we can then unlock driverless operations, which then makes the car be used way more than what it is used right now.